Hello. Um, I have been working a lot over the last couple weeks on porting the overlay services to Go and then starting to build overlay services on top of it. And I just kind of wanted to show off the progress here and then go into little details of how things are working. So, um, so I guess first of all, so I've got completely clean system right now. There's nothing in it. There's no databases. There's no anything. I've got just like SQLite databases plugged in for testing anyways. So I'm going to start by running this subsystem. This is just going to go out to Jungle Bus to get a queue of, it's looking at the money, all the money outputs. So this first step isn't really part of, I'm just kind of bootstrapping with data that I know is valid. So we're going to go run. So that's going to go, it's going to get all the money transactions from Jungle Bus. Then this process that I'm going to run now is basically going to one at a time essentially broadcast those transactions into the system as if someone was broadcasting them for the first time. Now, yeah, that's essentially it. So this is just going to run through all those transactions in order and fake broadcast them, submit them into the overlay. That's going to run through. And after I show this off, I'll go into how that actually works. I had thought I already cached a bunch of these, but apparently I didn't. Okay, it is done. So, if I look now at this, actually, we have this BSV21 topic database. So this is going to show all the different outputs that are now part of this overlay service. And then data about kind of the relationships between those outputs and other outputs. There is also this lookup database, which is where we're going to be storing information that allows you to look up the records within here. So right now, all we have for looking up data is this is the money token ID. So for all these transactions, we have that you can look them up by the token ID. Now at this point, this is the only token ID that the system's got, so everything has got the same value. But, did I not clean that out? Okay. So then I've got this fresh DB, which is completely empty. And what I'm going to do over here is I'm essentially just going to start up another overlay, another instance that is set to peer with this one that we just populated. And so it's going to reach out, negotiate what transactions is it missing and pull in any transactions that it's missing from the other one. So I think if I just hit this sync debug, let's go to the, oops. So again, this isn't coming from Jungle Bus or faux submission at this point. This is two overlays just trying to stay in sync with each other. And so far, let's look at our fresh DB. Let's look at the outputs. Oops. There where's the original BSV20? Let me just make sure I got the right one here and this is working. Boom. So all of those transactions synced over. Where's my... Ah, there it is. Cool. So let me exit out of this. So in order to pull this off, well, first of all, I guess I'll go into topics. So overlay services uses kind of, it's got two different configurable modules that you plug in. One are topic managers, and topic managers look at a transaction and it runs this identify admissible output. So it's basically kind of looking at the current state of the overlay. So what of the inputs do we already have in the system? And a beef that is a transaction being submitted. And this identify admissible outputs is going to basically say which of the outputs from this transaction belong to this overlay. Which of the inputs that already existed do I want to keep around? And so basically, all this is doing is basically saying, yes, this output this output belongs to this topic within this overlay, so keep it. So this BSV21 topic manager here for identify admissible outputs is basically it's looking at each of the outputs to see which ones contain BSV21s. It's keeping track of which tokens, of what token IDs are in these transaction outputs. And then if I have any, then I find the inputs and figure out if there's enough inputs to cover the outputs. If there are, for all the valid outputs, we tell the overlay, yes, keep these BSV20 outputs, they're valid. And so that populates this outputs table, which essentially has the out point, what topic we're in, the height of the block index, how many Satoshis are in the output, what the script is. That data is populated, but it's binary and it's not showing for some reason. The beef, we keep track of which other outputs this one consumes. And then we also keep track of which output this output was consumed by, or I guess really which outputs. Dependencies, I'll get to another time, and then we keep track of whether they're spent. So an overlay is really just kind of keeping track of a relationship between different outputs and whether they belong in this overlay or not. So that's the topic manager. And then there's this lookup service. And a lookup service, basically, they're kind of events for you to handle for when an output gets added to the system, when it's spent from the system, or when it's deleted out of the system. And at the interface level, let's see, do I have that open? No, that's a different window. I don't need to pull it up right now. So this lookup service has essentially these three events and then a lookup method, which is just a very generic query method. So then the place I'm at right now, so this is what I pointed out earlier, is right now I'm essentially saving for every token that's in here, just the ability to look at outputs by token. So other things I'll add here are probably who owns this token, or yeah. Anyways, So this is coming along really, really well. And I just wanted to share. Actually, one other thing to bring up here, and that is, all right, let's open this up. Info overlay. So there is this methodology that Ty created called GASP. And GASP is kind of a tool for keeping different overlays in sync with each other. Oops. And it communicates using these GASP nodes, and it's basically a transaction. Transaction and an output. So for a given output, it includes with it raw transaction and Merkle proof for that transaction. And I've had to slightly expand upon this, and I still need to have a talk with Ty to see if he's on board with the way that's doing. But there's an assumption in the, I can actually pull it up. So this is the TypeScript overlay services. And actually, let me. So the topic manager has another method I didn't really cover, but it's identify needed inputs. So that's basically, I can pass a transaction to this method. And for that topic manager, the topic manager will tell me which of the inputs of that transaction are needed in order to ingest that transaction into the overlay. The problem with this is, so we get a beef in, but the problem is with BSV21s, so like the normal rules with beef is as soon as your transaction has a Merkle proof. So if your transaction doesn't have a Merkle proof, the beef contains within it the previous transaction, so all your input transactions, as well as their Merkle proofs, and then your transaction without a Merkle proof, but with kind of all the context of all the inputs, such that the system can tell that your inputs are valid. Well, there's a bunch of kind of automated tools within the SDKs, which when you kind of update a Merkle proof or update a transaction with a Merkle proof, the beef will then drop out all the kind of input transactions. But with BSV21, if I'm looking at a beef and I need to tell it which input transactions I need to have run through the overlay, well, I have to know what those input transactions are. So I've extended this GASP thing just a tiny, tiny bit, such that when we call this identify admissible outputs, so in TypeScript, they have 3 fields: which outputs we're saving, which outputs we're keeping, and then this is used for bookkeeping later on that says these are the ones that have been removed from the system. But essentially, these are the 2 fields that you spit out of the topic manager to tell you what to keep around from that transaction. So in the Go side, let's go to the topic manager. Everything's pretty much exactly the same, but I've added a new field to this admittance instructions, which is essentially the topic manager telling the system that for the outputs that it's keeping around within the beef those transactions, it needs to include this array of transaction IDs which were in the beef to begin with. So the idea is here, when someone first submits a transaction, it doesn't exist on chain yet. They submit it into the system, and I just realized my light's off. They submit it into the system, and it doesn't have a Merkle proof yet, so all the parent transactions are there in that beef. Well, when it's syncing with other systems later on, and it already has been mined, so it has a Merkle path, so kind of the default ways of handling the beef would be those inputs are no longer part of the transaction. Well, when we, from the topic manager, say these are the transactions to include, then they actually get saved on our output as dependencies. So then when we're kind of, well, let me actually then go back to the GASP stuff. So, nope, types. So in the TypeScript of GASP, they don't have this field. So I added this other field that's basically a beef that contains dependencies that are required in order to ingest this transaction and make sense of it. And so then when we go to pass it into that submit method, let's see, where do I do that? Actually, it's an engine where I provide the GASP node. Nope. Submit, lookup. Yeah, so right here, when I actually build a GASP node to send out to a peer, I have the output dependencies, and I build a beef that contains all my dependencies. And so then on the other side, when I go to sync in from these things, where do I do that? That is in gas storage, I think. I needed inputs. Yeah, right here. So when I go to rehydrate this thing, if I've got a beef, I'm essentially merging that beef in with a beef for the transaction itself. And so I'm just kind of like adding that those contextual transactions back in before the system processes to make sure that it's got everything it needs and can handle it properly. So Ty, I will probably share this video with you to get your feedback on that, because without that, I'm not finding any way that that we can. Well, let me just, I guess, restate it one more time. Really, the problem is identify needed inputs without doesn't really work without being able to have what the outputs were that are being spent in that input. And within the whole overlay, that data will be available the first time that transaction comes in, and it just needs, basically that relationship just needs to be saved with it. Yeah. So that's it for now. This is coming along really, really awesome, and hope to keep being able to illustrate how we can start doing lots of things with these. So that's it for now. Have a good one.